And what we're talking about today is using properties of special parallelograms. We're going to go over different types of special parallelograms today, and then we'll get into more of some of the details of the different types and how they work in solving problems tomorrow. Now, the first three special types of parallelograms that we have is a rhombus, a rectangle, and a square. And these three have different properties to them. A rhombus is a parallelogram with four congruent sides. So a rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles, and a square is a parallelogram with four congruent sides and four right angles. So looking at these here, is a square a parallelogram? Is a square always going to be a parallelogram? Well, yes, a parallelogram is two sets of parallel sides. Does a square have two parallel sides? Well, yes. Well, so a square will always be a parallelogram. Will a parallelogram always be a square? Well, no. What else do we know? A rhombus and a rectangle are also a parallelogram, yes? So a square is always a parallelogram, but a parallelogram is not always a square. The same thing would be true for rhombus and rectangle, yes? Because a rhombus is a parallelogram, but a parallelogram is not always a rhombus. Is a square a rhombus? Can a rhombus be a square? Because what is a square? Is a parallelogram with four congruent sides and four right angles. What's a rhombus? So can a square be a rhombus? Because what is a rhombus? Four congruent sides. Does a square have four congruent sides? So can a square be a rhombus? Well, yes. Can a rhombus be a square? Not always. I mean, if we had a certain case where all four angles are right angles, then yes. But would every rhombus be a square? Well, no, because a rhombus is just four congruent sides. So a square can be a rhombus, but a rhombus is not always going to be a square. Now, can a square be a rectangle? Can we classify a square as a rectangle? Well, what's a rectangle? Four congruent angles, yes? Four right angles. Does a square have four right angles? So a square can be a rectangle, but is a rectangle a square? No, not always, because the only time a rectangle would be a square is if it has four right angles and four congruent sides. Are y'all starting to see this here? Because parallelogram is not our most general term. The most general term would be what? A quadrilateral, four sides. So if the only thing we know about a four-sided figure is that it has, well, four sides, we would call it a quadrilateral. Now, if we know it has two sets of parallel sides, we would call it a parallelogram because we have a little more information. Now, if we know all the sides are congruent, we'll call it a rhombus. If we know it has four right angles or all the angles are congruent, then we would call it a rectangle. And if it has four right angles and four congruent sides, then we would call it a square. We use the most specific terms. So this is our first corollary. A quadrilateral is a rhombus if and only if it has four congruent sides. So if it has four congruent sides, then it is considered to be a rhombus. A quadrilateral is a rectangle if and only if it has four right angles. So if it has four right angles, then it is a rectangle, or all four angles are congruent. Because either one of those terminologies is going to be interchangeable. Any questions on any of this here so far? A quadrilateral is a square if and only if it is a rhombus and a rectangle. Because we'll say this, rhombus and rectangle, because, well, it's a rhombus if all four sides are congruent, and it's a rectangle if all four angles are 90 degrees, or right angles. So, let's start applying this a little bit, and that's really what the homework assignment's going to be. For any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. So, if this is a rhombus, we know all four sides are congruent, yes? Because that's just by definition of what a rhombus is. By definition, a rhombus has four sets of congruent sides. And we also really have two sets of parallel sides. Because we know by definition a rhombus is a parallelogram. Now the question is, will angle Q and angle S be congruent? Is this going to be always true or sometimes true? Because these two angles are opposite angles, yes? Opposite angles in a parallelogram are what? Congruent. So this here would be always true, because opposite angles inside of a parallelogram are always going to be congruent. So that means any parallelogram, the opposite angles will always be congruent. So for this here, it'd be always, because it's a parallelogram. Questions on this here? Okay. So we still have another rhombus. And since it's a rhombus, the opposite side, or all four sides would be congruent. And again, we have two pairs of parallel sides. And again, we want to determine if the statement is sometimes or always true. We want to know if angle Q and angle R are congruent. What do we think? Sometimes or always? Okay. When would it be that these two angles would be congruent? Really, this is going back to parallelograms. Because we said opposite angles in a parallelogram are congruent. What about consecutive angles, angles that are next to each other? Would they be congruent, or would they be something else? What would these two angles be? Because I do agree with sometimes. It is sometimes. Because angles inside of a parallelogram, the opposite angles are congruent. The angles that are next to each other are what? 180. Angle Q and angle R are supplementary angles. That means that angle Q plus angle R, since they're next to each other, add together to be 180. So what would the case be where Q and R would be congruent? What would their measures have to be? 90. So it can be that they are congruent, but the only time that they would be congruent is if both angles measured 90. That's the only way it would work. Questions on this here? For any rectangle A, B, C, D, decide whether the statement is always or sometimes true. Explain your reasoning. So, a rectangle is a parallelogram. So a parallelogram means that the opposite sides are congruent, and because it's a rectangle, we have 4 right angles. We also have 2 sets of parallel sides because it is a parallelogram. Now let's see what the statement is, and we probably have just filled it in. AB and BC. Is it going to be sometimes or always true that AB and BC are congruent? Let's see here. AB would be this line here. BC would be this would be sometimes. It'd be sometimes. Because when would this be true that these 2 sides would be congruent? When it's a square, when all 4 sides are congruent. Because that would be the case, it would work. But it's not always going to be true. Not every rectangle will be a square, but every square will be a rectangle. Any questions on this here? Use your reasoning to determine whether AB and CD are congruent. Okay, well, since it is a rectangle, we know all 4 angles are going to be 90 degrees. Since it's a parallelogram, opposite sides are congruent and opposite angles are congruent. Do I need any more information to kind of figure out whether A, B, and CD are going to be congruent? So is it sometimes or always? Always. You're just one question ahead. This is always mainly because it is a parallelogram. The opposite sides in a parallelogram are congruent. So this would always be true. Okay, so now we're going to look at a square. For any square, JKLM, is it always sometimes true that JK is going to be perpendicular to KL? It would be always, yes? Because what they're saying is that JK and KL, if they're perpendicular, it means it's going to make a right angle. Well, if it's a square, all 4 angles are going to be what? Right angles. Because that's by definition what a square is. It also that all 4 sides are going to be congruent. So by definition, a square has 4 right angles. So each of the sides would be perpendicular to each other. JK and JM would be perpendicular, as well as our other 2 sets. Because all 4 angles are going to be right angles. Questions on this here? Let's see here. I feel like we're getting the hang of this, kind of getting the ideas, our heads wrapped around on how these things work together, yes? All right, I think we're good with that one. Okay. We're pretty much halfway done. The last thing we're going to do is classify. Classify. A quadrilateral has 4 congruent sides. Okay, well, that means all 4 sides are going to be congruent. And 4 congruent angles. Okay. Sketch it, so we did. I sketched it here. Now we need to classify this here by its name. So let's start out by classifying it by any name. So what is the most general term we could use for this here? Well, our shape would be what? Because it would be a polygon if we really wanted to get really general, because a polygon is any closed figure. But how many sides do we have? 4, so we know this is at least what? A quadrilateral. Because it has at least 4 sides. That's it. Okay. Now, can we necessarily name it a parallelogram yet? Because it didn't say anything about parallel lines, did it? No. But what else do we know? Well, 4 congruent sides means it's a what? A rhombus. Because a rhombus is a 4-sided figure with what? 4 congruent sides. Well, it also means if it is a rhombus, it's also a parallelogram, because a rhombus is a parallelogram with 4 congruent sides. We can say it's also what? A rectangle. And a square, yes. Because this one worked out to be everything. Now, looking at all these here, if I wanted the specific name for this one here, which one would we pick out of all these here? A square, because when we're naming it, we want the most specific name, or we really just want to name it or classify it. We classify it by the most specific term out of all of them. Now, if we want to list all of the names for this here, we would list all of them out. If we want the most specific, it's talking about square. Okay. Let's look at another one. Classify the special quadrilateral. So looking at this here, what do we know for sure? It is a rhombus. Rhombus. It is a rhombus. Which would mean it would be a parallelogram and also a what? Quadrilateral. And that's it. But the most specific term would be a rhombus. Okay. Okay, so looking at this here, let's classify it. Let's use all the names. So what do we know for sure? Let's say what? It's a quadrilateral. It has 4 sides. What else? It's a parallelogram because we do have 2 sets of parallel sides. It did draw that in for us, yes? Now, do we have any other information on this figure? Rhombus, because this opposite sides would be congruent. And we already knew 2 of the sides were congruent to each other. And the sides opposite would be congruent to them. So this here would be a rhombus. Can we say anything further than this here? Do we know anything about the angles? No. We know that the opposite angles would be congruent, but for me to be able to say it's a rectangle or a square, I would need to know that all four angles are congruent to each other. So we can't say anything more than this. And the most specific term that we could have for this is a rhombus. And that's it for this here. Okay. We have these two here. Okay. So again, like we've been doing, state all names for each figure. So looking at this first one here, 4 congruent sides, 4 congruent angles. So it's a what? Quadrilateral, a parallelogram. And we know it's a parallelogram because it is a square and a rectangle and a rhombus. Because it's a square, rectangle, and a rhombus, it has to be a parallelogram, and it has to be, well, it's obviously a quadrilateral. Questions on this here? Yeah? So looking at this number 2 here, so what's the one thing we do know for sure? It's a what? It's a quadrilateral. It has 4 sides. Now, are any of the sides parallel to each other? Do we know anything about the side lengths? Do we know anything about the angles? Do we know anything besides the fact that it has 4 sides? So what can we call it? We can only call it a quadrilateral because we only know that it has 4 sides. That's it. So number 4. Well, we know it's a rectangle because it has what? 4 right angles, yes? Well, since it's a rectangle, it means it's what? It's a parallelogram. And it's also a quadrilateral. It has 4 sides. So a lot of these figures, as long as they have 4 sides, it will be a quadrilateral. It's just going from there to determine if it's a parallelogram, rectangle, or square, or rhombus. Any questions on any of this here? Okay. So let's look at this here, number 5. What can we say about this one here? What can we name it? It is a quadrilateral because it has 4 sides. It is a parallelogram. So do we know all 4 sides are congruent? Because does it tell us that all 4 sides are congruent? No. So we need to actually have it stated that all 4 sides are congruent. Because unless it's actually stated and specifically stated in the picture, then we can say that it is true. Anything that's not stated or that we can prove in some way, shape, or form, we can't say. We can't assume it. Because one of the biggest things in geometry that hopefully you'll learn after this here is that the pictures will lie. They won't always look exactly what we think they should. And I did this earlier in the semester, earlier in the year, or last semester. I think I drew 89 degrees in a 90-degree angle, yes, and used a protractor and showed you guys that. The difference between 89 and 90 degrees is barely, I mean, you have to go out decently far. Because if we're about an inch or 2 inches away from it, the length of the line is only an inch or 2 inches. The difference between 89 and 90 degrees isn't even visible. You can't see it. So it's hard to tell. So with side lengths and angles, unless it specifically tells us what they are, we can't assume it. So for this here, we can just say it's a parallelogram. Now, it could be that it could be a rhombus, but we don't know for sure because we haven't been told anything else. But that's it. And I think we're good with those. Most of this here. I think these are the last two. We'll do these here, and then we are done for today. Now, looking at number 10. Let's skip 2 of them. Looking at number 10. Well, we can call this a quadrilateral. Because it has 4 sides. Can I say that this is a parallelogram? Well, if it's a parallelogram, the opposite sides are congruent, yes? Are the opposite sides congruent? Well, it'd also be a parallelogram if the opposite angles are congruent. Are the opposite angles congruent? So we can't say that either. So we can't say anything else about it because if it isn't a parallelogram, it can't be a rectangle, it can't be a rhombus, and it cannot be a square. So that's it. So this here is just a quadrilateral. So let's look at this last one here. Now it is a quadrilateral because it does have 4 sides. Can we call it a parallelogram? You can call it a parallelogram because the opposite angles are congruent. And the opposite sides are actually congruent. So that works out. Can we name it anything more specific than this? This would be a rhombus, yes. Is all 4 sides are congruent. So that works out. Now, can I name it a square? No, because all 4 angles are not what? Congruent. And that is it. That is all we're going to do here today.